In this video, we'll show how to find the work done by force pumping water from a tank. So in this problem, we have a tank that is shaped as an inverted cone. So it looks something like this. And the height is 10. And the base radius is 6 feet. And the tank is filled to a depth of 8 feet. So the initial level is at 8 feet. And water is pumped over the upper edge of the tank until 3 feet of water remain in the tank. So we're going to this level. And how much work is required to pump out that amount of water. So first of all, let's introduce the coordinate system. So we're going to draw the x-axis pointing down. So this is the origin, and at the very bottom it's going to be 10. We're going to divide, we're going to partition this segment into sub-intervals, and ith interval is defined by representative xi star, and we have a layer of water delta x deep, and we're going to find the amount of work that it takes to pump that layer of water. So basically what we're doing here is we're pumping this much water. How high? We're pumping it this high. To find the mass of this layer, we're going to multiply the density by the volume. To find the volume, we need to find the area of that circle and multiply it by the height, which is delta x. And to find the radius, to find the area of this circle, we need to know the radius of the circle, and the radius of the base is actually a function of xi star. So to figure out what is xi star, I'm going to look at the cross section of that tank. The top is 6. The total height is 10, and the distance from the top to this point is xi star, and we're looking for the value of this for the length of this line segment. We're going to use the similarity between these two triangles. So the smaller triangle is similar to the larger triangle. That means 10 minus xi star divided by r is the same as 10 divided by 6. That means if I want to know r, I can just take 6 multiplied by 10 minus xi star and divided by 10. So this is my formula for r, and now I can easily find the area of the cross section and set up the integral for finding the work. So area is equal to pi, simplifying 6 over 10 as 3 over 5, 10 minus xi star squared. That's the area of the cross section. The volume of that layer then will be pi times 3/5 10 minus xi star squared times delta x, and the mass will therefore be the density of the water times the volume, which is pi times 3/5 of 10 minus xi star squared delta x. The density of the water is 62.4 pounds per foot cube, so we can replace rho with that value. And now the amount of work done by pumping this much mass of water by this high is equal to 62.4 pi 3.5 10 minus xi star squared times xi star delta x. So if I want to find the total work done, I have to set up the following integral. Since the layer only goes from 2 to 7, we're integrating this expression 62.4 pi 3 over 5 10 minus x squared x dx, and this is a simple integral. We can take all the constants out, so we have 62.4 times 3 times integral from 2 to 7, and we're integrating 10 minus x squared times x, so it's going to be 100x minus 20x squared plus x cubed dx, and finding antiderivative of that is pretty straightforward. So we have 50x squared minus 20³ x cubed plus 1/4 x to the power 4. And we evaluate this integral on the interval from 2 to 7. Why is it again from 2 to 7? Because the way we set up the coordinate system is the 0 on top, 10 at the bottom. So when the water is 8 units high, that corresponds to the x value 2. When the water is 3 units high, that corresponds to the value 7. I'm going to make some room over here. And almost there. So plugging in 7 into this function, we get 50 times 49 minus 20 over 3 times 343 plus 1 over 4 times 7 to the power 4 minus 50 times 4 plus 20³ times 8 minus 1/4 2 to the 4 is 16. And I'm just going to plug it in the calculator. So I got the following results. So it's 187.2 pi times 207.45. Which results in the following answer, which is in foot-pounds. So this is how much work it takes to pump the water from the given tank.